Welcome back to day 6 of our Python series. Today, we are mastering how data transforms from one type to another and how to make your programs interactive using the input function. Yesterday, we covered basic data types. But what happens when you try to add a string to an integer? Python has rules for this, known as type conversion. Let's dive in. First up, implicit type conversion. This is Python being smart. It automatically converts one data type to another without any user intervention to avoid data loss. Imagine adding an integer, say 5, to a float, 2.5. Python promotes the integer to a float so the result is 7.5. It chooses the higher A type to keep the precision. Look at this, A equals 10, B equals 5.0, C equals A plus B. Even though A is an int, the result C is a float. Python handled that for us. No extra work needed. However, Python isn't a magician. If you try to add the number 10 to the word a10, a string, Python will throw a type error. It doesn't know how to merge them. This brings us to explicit type conversion, also known as typecasting. This is where we tell Python exactly what we want a data type to become. We use predefined functions like int. If you have a string of 100 and you need to do math with it, you wrap it in int to turn it into a real number. Similarly, float converts a value into a decimal. Even if you pass the integer 5, float 5 turns it into 5.0. This is crucial for precise calculations. What if you want to print a message like your score is followed by a number? You must convert that number into a string using str before joining them. Think of typecasting like a translator. Without it, different parts of your code speak different languages. You are the bridge that makes them work together. Now, let's make things interesting. Up until now, our variables were fixed. But real apps need user data. For that, we use the input function. When Python hits an input line, it pauses. It waits for the user to type something and press enter. This is the first step toward building real tools. The syntax is simple: variable equals input, prompt text. The prompt tells the user what to do, like enter your name or enter your age. Here is the most important rule of day 6, the input function always returns a string. Even if the user types 25, Python sees it as 25 foot in quotes. If you try to take that age and add 1 to it, your program will crash. Why? Because you can't add a number to a string. This is where our casting skills come in. To fix this, we wrap the input. Age equals int, input, enter age. Now, the string from the user is immediately converted into an integer we can use. Let's write a small script. We'll take two numbers from a user, add them, and print the total. Watch what happens if we forget to use int, it just joins them. If the user enters apples when we expect a number, the int function will fail. This is a value error. Learning to read these errors makes you a pro. You can nest functions like float input. This is very common in Python. It reads from the inside out, get input first, then convert it to a float. Let's try a challenge. Create a program that asks for a product price and a tax rate. Remember, prices and taxes usually have decimals, so use float. Calculate the total and print it. To print it nicely, you'll need to convert that final total back into a string using str to concatenate the message. Why does this matter? In data science or finance, a small mistake in type, like losing decimals, can lead to huge errors. Python strictness is your safety net. Pro tip: always give clear prompts in your input function. Instead of just a value, use a please enter your hourly wage. It makes for a better user experience. Let's summarize: int for whole numbers, float for decimals, and str for text. These are your three primary tools for explicit conversion. What about bool? Yes, you can convert values to booleans. Empty strings or zeros become false, while almost everything else becomes true. We are on day 6 of 90. Mastery comes from understanding these small building blocks. Type conversion is the foundation of data processing. Your homework today: write a script that asks for a user's birth year and calculates their current age. You'll need to use int and some basic math. Share your code in the comments or on our LinkedIn group. I'll be checking them to see how you're handling the conversion logic. Tomorrow, we dive into operators, how to perform complex math and comparisons. Make sure to subscribe to Edulexis so you don't miss day 7.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.